All right, welcome to our Unit 4, Day 3, where we're investigating the slope by calculating the rise over run. Hopefully you've already done the student or the Desmos activity here that's outlined on this. If not, go back to this page and try that Desmos activity, and that will get us set up for what we are learning today. This is a brief little summary on what we discovered in that Desmos activity, in that how to calculate slope. Remember that slope is a measure of the steepness of a line. So instead of just saying that we got a steep line or a less steep or all that sort of stuff, we can actually attach a number to it to be a little bit more mathematical about your explanations. You can have positive or negative slopes, just like you have positive or negative correlations. Slope can be measured by how much a line rises over how much distance it covers, which is the run. And so slope can be found by taking the rise divided by the run. And we would see that as a rise and a run from any 2 points on the line. We also discovered that there not only is there positive or negative slopes, but also have to deal with horizontal and vertical lines. But positive slopes, of course, represent positive correlations, which means if you're looking at it from left to right, it goes up. Okay, so as the independent variable increases, the dependent variable increases, and it goes in that forward going up. Okay, as you read it from left to right. So from this point to this point, you are rising and going up. So you get a positive slope. Vice versa, if you're reading from left to right, you are going down. Okay, so as the independent variable increases, the dependent variable decreases, and we have something going down, and that would be represented with a negative slope. We also looked at horizontal lines, and it turns out that horizontal lines have a slope of 0. Why? Because there's no rise. There is a run, but 0 over 5 is the same as 0. So we just say that it's 0. We say that all horizontal lines have a slope of 0. And the opposite of that is a vertical line. And in the activity, it says it's undefined. And the reason is it's undefined is because you would have a fraction here where there's a rise, say 6, but the run would be 0. And 6 over 0 is not allowed. Okay, you can't divide by 0. It's impossible. You can punch in your calculator, you'll get an error. So we wouldn't say that this is 0 because 0 represents this. So we say it's undefined. Another way of saying it is there's no slope or it doesn't exist. Okay, so all of these are the same thing. That means that you're talking about a vertical line, and we don't describe this. We don't have a slope for that. We do have a slope of 0 for this, but not for this. The way I remember it is I think of downhill skiing. This you would ski uphill, this you would ski downhill. This, of course, would be more fun. Here, if you were skiing on this hill, you would get 0 skiing done. But here, if you tried to ski down this cliff, you wouldn't exist. So that's the way I remember it. I can't ski down this. There's no slope. I can ski on this. It's just very boring. It just sits there and I don't move. So M is 0. And here I have our positive and negative. Okay. This is summarized in the Desmos activity with this graphic where we have positive, negative slopes, slope of 0, and undefined. Now, if we go and look at our Desmos activity, you learned that the slope was the rise over run. So in this case, you can take any 2 points, for example, these 2 points here, and calculate the rise and the run. And so our slope is rise over run. In this particular case, you can see that you go up 2 squares. You could actually mark that out if you wanted. Okay, and go count it out like this. 1, 2, and then 1, 2, 3. Our rise then is 2. Our run is 3. And so the slope is 2 over 3. Of course, we would just simply write it as 2 over 3. We wouldn't have these colors, but we rise 2, run 3. Okay? Now, I chose those 2 points, but you could choose any 2 points. So, for example, if I wanted to choose this point and this point, notice that the rise is a bigger rise. So we would count 1, 2, 3, 4 squares. So the rise is 4. And the run is 1, 2, 3, 4, 5, 6 squares, 4 over 6. Now, 4 over 6 represents the slope of this line, and 4 over 6 is correct. But of course, 4 over 6 reduces to 2 over 3, which is exactly what we had before. Why? Because this is the same slope. It's going to have the same line. It's going to have the same slope, whether you choose a big triangle here or the little triangle. It will still reduce to the same thing. There's the big triangle and the little triangle still representing the same line, so the slope is the same. 2 over 3. You can go even bigger here. Here's one that goes from this point all the way to this point. So this time you're going to rise 1, 2, 3, 4, 5, 6. So you're going to rise 6. And your run is 1, 2, 3, 4, 5, 6, 7, 8, 9. But of course, 6 over 9 reduces to 2 over 3. You can even imagine it like this. Any of these squares are these steps. These are little 2 over 3 steps. You can see the 2 over 3 steps. Or you can take this one big step. You still get to the same spot. It's still representing the same slope. All of them are the same as saying 2 over 3. Okay, so it doesn't matter which two points you pick. You can even pick these points. But the problem with these points is it's really hard to count. So harder to count. If you didn't know how high this was, it'd be hard to count from here to here. So it'd be difficult to say what the slope or what the rise is. Similarly, the run, it's hard to count. So you'll want to pick two spots that are easier to count, like this point to this point, or this point to this point, like we had before. Regardless, even if you were able to count, you could count up whatever that ratio is. From here to here, it turns out that the rise is probably some ratio of 2 over 3. Okay, it's just, you might as well pick points that are easy to count. Here's an example of one that's going down. It's a negative correlation. Okay, so we should have a negative slope. We still say it's rise over run, but we say the rise, which usually means something to go up, we're going to say the rise is actually going down. So the way we deal with that is by saying that the rise is negative. So here we go, 1, 2, 3, 4, 5, 6, down 6 over a run of 2, okay? Your runs are always going to be positive because you're reading from left to right. So your runs will always be positive, but your rises could be going up or going down, and that number would be negative. Of course, negative 6 over 2, that reduces as a fraction, negative 3 over 1. You could write it out as a negative out this. You could put the negative on the bottom, but we said runs aren't really negative, so we want to consider them either here or on the top. And of course, 3 over 1 actually is a 3. So we would probably just say that the slope is negative 3. We wouldn't necessarily say 3 over 1, even though it means exactly the same thing. Notice here that I went from this point to this point, but there are a smaller count that might have been easier. We could have maybe drawn from here. Oh, that wasn't very straight. Over there, and say down 3 over 1, and we get the same spot. In fact, you can see those spots here, down 3 over 1, down 3 over 1. All of it means the same spot. Okay, so you could have picked these 2 points or these 2 points or the big points or maybe even other bigger points. All of them would reduce down to negative 3. And this last one I just want to point out, it doesn't matter if all your points are in the negative. So for example, this line seems to be all over on the negative side of x. We're still going to pick 2 points. So for example, if I go from here all the way up to right there, that would be a rise of 10. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I could draw a little line here to help me. So there's a rise of 10 and a run of 1, 2, 3, 4. 4. So 10 over 4. Does that reduce? Sure, 2 goes into both of them, so that can reduce to 5 over 2, which means I probably could have found an easier spot to go. Maybe I could have gone, let's choose a blue thing here. Maybe I could have gone up 5 and over 2. And look, there I am, right back on that dot. Okay, so up 5 steps over 2. So I could have found that one instead of the 10 over 2. Doesn't matter. They both reduce to the same thing, and the slope is still 5 over 2. Okay. All right. So that's your rundown and a summary of the activity. So what I'd like you to go do now is go back to Desmos and enter this code. And this is going to be a little quiz. So if you remember from the first Desmos activity, when you typed it in, it would tell you if you were right. This one, you're just going to type it in. It's not going to tell you whether you're going to write, and I'm going to mark these and see how you did. Okay, but it'll look very similar to the first Desmos activity. So if you haven't done that first Desmos activity, you definitely want to do that first before you go off and try this quiz. After you try the quiz, there are some practice questions. The reason I'm giving you some practice questions and a little quiz is because this is such an important concept moving forward, calculating slope. So I'm going to suggest that after you do this quiz, you try these pages out of your textbook as practice. You're not going to hand it in. This is just regular homework, so I'm not going to be checking that homework. But it is such an important concept that I want to make sure you feel very, very confident about this. All right. So good luck with this, your quiz, and maybe you can do some practice. And that's the slope using rise over run.